underlying phenomenon. Okay, the other day, I just pulled this out. The guy said, some environmental activist said, corn likes it cool, but global warming is raising temperatures across the nations. Hotter fields will mean lower yields for corn and eventually the rest of agriculture. Guys, there's some limit to this where it gets too hot. But plants like longer growing seasons and they like warmth. And it was true in the Middle Ages, and it's true today. You know, we're having bumper crops in all our cereal grains, really in all our crops. The one problem we've had in agriculture last year has been some early freezes and some late freezes this year that hurt some of the fruit industry. Okay, hurricanes. As y'all may know, Katrina was supposedly caused by global warming, and in fact, a lawsuit is going forward where Exxon and a bunch of coal companies and whoever are getting sued for creating Katrina. I kid you not, I can't wait to see how that court goes. But they're actually getting sued for creating Katrina. Now, firstly, I think it is a low point in science journalism in the United States when anybody says that one particular climate variable can cause a single hurricane. I think that's insane. Okay. The second thing is hurricanes are notoriously hard to count, because Katrina was only a disaster because it hit a major city. If Katrina had hit, does that mean if Katrina had hit an uninhabitable part of the Texas coast, like lower Padre Island, then that wouldn't have been global warming because there would have been a lot of damage, it would have been the same storm. And so a lot of this is affected by, just the luck of where the thing hits landfall, which has nothing to do with climate change and global warming or anything. So here's the way you're supposed to measure hurricanes. The way you measure hurricanes is you don't count them because they're all different sizes, they're different lengths. You take what's effectively integration, if you all know what that means. You combine the number of hurricanes a year, times the length of each of those hurricanes, times the strength of those hurricanes at each point in time through its life, okay? And that gives you a total energy in those cyclones, a total cyclonic energy, both of hurricanes. And if you add that up, this couple months ago, I'm going to say all the time, we have many satellite things that only go back to 79, so I won't say all the time. But for the length of time we've been able to measure this variable, we hit the lowest that we've ever measured. Bet that made the news. Y'all all saw that, right? You saw that news where we hit the night 2009, we had an absolute low point of hurricanes. And, no, you didn't see that, did you? Secondly, tornadoes. And I put this in because Al Gore talked about this in his movie. He talked about hurricanes. He uses this data. Okay? And you look at hurricanes. It goes from the tornadoes. It goes from 200 in 1950 to 6 bajillion to 1,000 or something in 2004. And you say, oh my God, there's a trend there. That's horrible. If you go to the page, in huge block letters on the page where this data comes from, the NOAA, the weather folks for the government, they have in huge block letters, like 44 font. Be careful with this data. This is a measurement issue, not a natural science issue. Here we have Doppler radar, we have storm chasers, we have TV news, we have more population. Over here, we had none of that. This is a factor that we weren't measuring tornadoes, not that there were fewer of them. And so what they say on that page, I wish Al had looked at the page that he got his data from, is it says don't use this chart, look at the F3, F4, F5 tornadoes, those are the big ones. And because we didn't probably miss those in 1950. So look at the ones that we don't need technology to find, and you see the trend. If anything, it's down. So there's no trend in tornadoes, but people misuse the data to say it. Now I will say, remember last year we had the last 2 years aren't on here. For some reason the government's slow in updating this. I didn't have the 2 years. 2008 was pretty big. It was like up here. It was a pretty big spike. And everybody said, oh, it's global warming. We're seeing the most tornadoes ever. Well, the most tornadoes ever. It's the most tornadoes in a decade. We're seeing all these tornadoes must be global warming. I always laugh at that because they all happened the first 5 months of last year, which were the coolest 5 months that we'd had in like 15 or 20 years. But it was global warming. But this year, we've had the lowest number of tornadoes that we've had maybe ever since we've been recording it. We've just had a dead tornado year this year. Y'all saw that in the news, right? No, you didn't. Okay, anyway, so no trend in tornadoes. Okay, we're all worried about Arctic ice, and this is very worrisome. The Arctic Ocean is warming up, icebergs are growing scarcer, and in some places the seals are finding the water too hot. Reports all point to a radical change in climate conditions, and here's to unheard of temperatures in the Arctic zone. Expeditions report that scarcely any ice has been met with as far as 81 degrees 29 minutes north Great masses of ice have been replaced by moraines of earth and stones, while at many points, well-known glaciers have entirely disappeared. And this is right from the U.S. Weather Bureau in 1922. And so, one of the things about Arctic ice, and it has been low on a 30-year scale the last couple of years, and we're going to look at the numbers, but there was no reasonable way to measure Arctic ice before satellites, because it'd just be catch as catch can. Where did ships run into it? We didn't really keep very good track of it. They did ice core analysis in Greenland, and have seen back in, and we have the same thing across the Arctic, that the Arctic was very warm in the 30s and 40s, just like the U.S. was warm in the 30s and 40s. The Arctic was very warm, perhaps as warm as it is today in the 30s and 40s. So it's okay to be worried and check in the temperatures and see if anything unusual happening. As always, I'm not telling folks not to check, but the temperatures that we're seeing in the Arctic and the melting of ice we're seeing in the Arctic is not unprecedented. We actually had far longer sustained levels of the same temperatures back in the middle of the century, but we didn't measure up there. We didn't have temperature stations. We didn't have satellites. Okay, last year, this was in the Republic. This is the anomaly again, I'm sorry. Actually, the total ice is a huge number. This is only a small percentage of the total ice. But this is an anomaly. The ice was down versus normal or versus average. And on October something or another, it hit what the Arizona Republic called an all-time low. Well, not quite an all-time low. All-time for Arizona Republic, I suppose, being 1978. But it was an all-time low since we looked in 1978. It was a low number, absolutely. Interestingly, on the exact same day, I'm talking about the exact same day, in the Antarctic, we hit an all-time high on sea ice. Exactly parallel. Almost by the same amount. A little more loss in the Arctic than we had gained up there. You all saw the Antarctic thing in the press, right? About being a lot of extra ice there. Okay, so yes, there are funny things going on in the Arctic. The Arctic has been warmer recently. The ice is mostly recovered, but the Arctic has been warmer. The Antarctic has been colder. And I tell you, if you're worried about sea levels, you should be more worried about the Antarctic, because it's the Antarctic that has 90%. The sea ice doesn't matter. If sea ice melts, the sea levels don't change a bit, just like ice melting your glass doesn't overflow your glass. It's the land ice that matters, and 90% of the land ice in the world is in Antarctica. Glaciers are fascinating. Remember I told you I would come back to glaciers. We've tracked glacier recession. That's something that we can do. That's something that geographers have done for hundreds of years. It's something they can do. They go out and measure glaciers and see how different they are. And it's something that was well within the technology in the 17 and 1800s, because you just see how far the glacier comes. And so glaciers were increasing through the 1700s because of the Little Ice Age, which ended around 1800. After the Little Ice Age, glaciers began to retreat. And they have retreated consistently all the way to now. The only thing that's happened is maybe the retreat has actually slowed down. It's actually reversed itself in certain places in Europe. So yes, when the alarmists go to the glaciers and say the glaciers are retreating, they are retreating. And they were retreating in 1950, and they were retreating in 1920, and they were retreating in 1900, and they were retreating in 1850. It's a trend that has gone on for 200 years. And the trend really hasn't changed except maybe to slow down. And what you have to believe that the current trend in glaciers has anything to do with man-made global warming is you have to believe that somewhere right here, some natural process that was causing the glaciers to melt stopped, just halted, or somewhere in this, because it didn't have to be all the time, but the natural process had to halt, and at exactly the same time, man-made CO2 took over and kept it going at the exact same pace. Or you could just apply Occam's razor and say there's just been a linear constant warming trend since 1800. Okay, just to give you two examples, people actually trudge around here. This is Glacier Bay in Alaska. I've been up there. I don't know if y'all have been. It's beautiful up there. This is where the front of the glacier was in 1794. This is where it was in 1860. Somewhere around here we started burning a little bit of coal in London. Here it is in 1907. We've added a little bit of CO2 in the atmosphere. Here it is in 1907. And this last little bit, so all of this receding happened by 1907, which is before most of the CO2 was put in the air. This amount happened between 1907 and today. That little bit. Same thing, here's a famous glacier in Greenland that's often used as a case because it's backed up the last couple of years. It's receded a bunch of years here. But it started receding back in 1851. It steadily receded. It's accelerated a little bit recently. Some of the in turn, some of the Alps glaciers have actually decelerated and reversed and started growing in the last few years. So glaciers demonstrate a constant trend as recovery from the little ice age. And you see the same thing with sea level. Sea level goes up for two reasons. One, melting ice.